The instructions are for us to find the derivative of the following with respect to x. So find the derivative of the following with respect to x. Okay, so let's say we have, for question 1, y equals x to the 6th power cotangent x. Okay? So if you notice, you have a product of two functions, this 6th-degree monomial and then this trig function here, cotangent x. Let's go ahead and write down all the formulas that we're going to use for this problem. The first formula we're going to use is the product rule. uv prime equals vu prime plus uv prime. For x to the 6th power, we're going to use the power rule. X to the n prime is equal to n x to the n minus 1. And then for the trigonometric differentiation, the derivative of cotangent x is negative cosecant square x. Before we use the product rule, what we're going to do is we're going to label the functions u and v. Since u comes first in the alphabet, the first function will be called u. So this will be u times the second function, cotangent x, will be v. Now if we apply the product rule on this label right here, we have v times u prime plus u times v prime. Now let's apply this formula to these terms right here. So v is cotangent x. That will be multiplied by u prime x to the 6th prime plus u, which is x to the 6th. That will be multiplied by the derivative of cotangent x. Alright, so let's go ahead and differentiate where applicable. We have cotangent x times the derivative of x to the 6th. That's x to the 5th plus x to the 6th times, this is negative, right? Negative cosecant square x. And then when we simplify this and refine it, we have our final answer, 6x to the 5th cotangent x. This minus here will be multiplied by this plus, so negative x to the 6th cosecant square x. That, ladies and gentlemen, is your final answer. We want to find the derivative again. So let's say you have y equals 5 minus x over 2x plus 1. Okay, this problem could look easy and straightforward, but you want to proceed with caution. Alright, so what formulas are we going to be using for this problem? We have a quotient of two linear functions, so we definitely have to use the quotient rule. U over v prime, which is vu prime plus uv prime, vu prime minus uv prime divided by v square. And then we will also use constant multiple rule. Derivative of a to the x is simply a. So now we have y is 5 minus x divided by 2x plus 1. The numerator function is u and the denominator function is v. Okay, so we have u over v prime Let's write on the quotient rule again. V times u prime minus u times v prime over v square. Okay? Now let's apply this label to this problem right here. If we're looking for y prime or dy dx, the y dx is going to be v, the denominator, 2x plus 1, times u prime, 5 minus x prime, minus u, 5 minus x, times v prime, the denominator, prime, this entire expression right here divided by the denominator squared. Alright, so let's go ahead and proceed with the differentiation. We have 2x plus 1 times derivative of 5 is 0, derivative of negative 1x. Using this rule over here is going to be negative 1 minus 5 minus x, derivative of 2x plus 1. Derivative of 2x is just 2, and the derivative of 1 is 0. Okay? So we have all that divided by the denominator squared, 2x plus 1 quantity squared. Let's go ahead and simplify. The y dx is going to be negative 2x minus 1. And then you distribute the 2 and the negative. You have negative 10 minus times minus. This becomes plus 2x. So positive 2x right there. And this entire expression divided by 2x plus 1 square. Let's go ahead and simplify. We're going to have the y dx is equal to negative 2x plus 2x add up to 0. Minus 1 minus 10 is negative 11 divided by quantity 2x plus 1 square. Alright, so that's the derivative of y with respect to x. Alright, so for problem number 3, what if we want to find the derivative of the following function? For 3, y equals the square root of 4 minus 5x. If you take a close look at this function, you notice that we have a composite function. The outer function is a radical function and the inner function is a linear function. So that will impact our formula selection. Okay? So these are the formulas that we are going to use. So since we have composite functions, we're going to have to use the chain rule. So if you have f composed with g of x prime, you're going to carry out the derivative of the outer, which is f, evaluated at the inner, which is g of x, multiply that by the derivative of the inner. Chain rule. We are also going to make use of the derivative of radical functions. The derivative of root x is 1 over 2 root x. And then we're also going to use the constant multiple rule. The derivative of ax is simply a. Okay? Alright, let's go take a look at the problem. Y is equal to the square root of 4 minus 5x. Now, to use the quotient rule, the chain rule, we're going to decompose the function first. Okay? So the outer function, we're going to call that f, which is just root x. And then the inner function, we're going to call that g. Okay? So step 1 in applying the chain rule, is to decompose the functions. Alright, so after decomposition, you differentiate both functions. So f prime of x is going to be 1 over 2 root x. And then g prime of x is going to be negative 5. The derivative of 4 is 0. So if you differentiate negative 5x using this rule, the coefficient of x is negative 5. So g prime of x is simply negative 5. Now using your chain rule, this is the derivative of the outer. If we evaluate it at the inner, simply means we are going to take g of x and plug it into all the x's. And then we're going to multiply that expression by the derivative of the inner. Okay? So let's write down our final answer. In its unsimplified state, dy dx is going to be 1 over 2 root 4 minus 5x times negative 5. Okay? If we want to refine it, make our answer look pretty, simply multiply negative 5 by 1. We have 5. Negative 5 divided by 2 times the square root of 4 minus 5x. And that is our final answer.